Everybody see that okay? Someone give me a yes. Okay, so ca2. Next week during your lab time, right? So that's 3 sessions on Monday, 1 on Tuesday. It's not online. You must be present in the lab, and don't start asking me for stupid supplementals because you won't get them, right? Unless you have an official doctor's note. 25%, blah blah blah. Part 1. Moodle question based on lab material covered since start of term. When I say Moodle questions, actually that'll most likely be paper, right? Written on paper. So there'll be questions. 8 marks, so that's roughly a third of the marks. It could be on any lab we did. They are not multiple choice questions. You have to supply answers. You will not be asked to do a Banker's matrix or a rank diagram again, but you could get asked something on deadlock. So just to be specific, what that means is I could ask you anything we did, commands on this lab. Well, obviously not the same questions you got before, but there might be some other different ones, right? Similarly here, I could ask you from there. I'm not going to ask you those. And then obviously you could get something asked on semaphores. You could have got asked on any of that, any of those. There's separate questions on these, but what I'm trying to get across to you is if you don't know your labs, you're going to have a problem in that area. Okay, that's the first part. Second part, 2 process thread semaphore scripts. So there'll be 1 semaphore question and there will be 1 script question. So when I finish this, going through this thing, I'll go through a couple of those just to make sure that you got, to give you an idea of what you need to know. Note that, okay? So they're worth 10 marks. So this is quite a big part. And I warned you about this, that, you know, if you want to get an A in this CA, you're going to have to know how to do this stuff. You won't get an A without it, all right? The average mark in CA1 was about 60. I told you that CA1 was easier than CA2. So again, this is the bit that will, the people who should get an A will get an A. People who maybe shouldn't get an A won't get an A. Simple as that. You will need to download some files from Moodle to your environment. You will be trying to fix some semaphore and some script issues, okay? And then what you fix, you upload into Moodle and I get to correct it. All right, that's that. And then the last one are, these are the gimme marks, okay? They are worth 7 marks. If you do not take these seriously and get most of them right, you are being a silly bitty, all right? Because these are the easiest marks on this CA. So I've given you loads of samples, I've given you the solutions, and you really need to make sure that you maximize these marks, because I think these are the easiest marks on the CA. These are not easy, some of these are not easy, all right? So I'm going to go and now spend some time. No, not a single person sent me a question. I did have an old question from a month or so ago that somebody asked me, so I'm going to go through that now. So I'm going to spend a little bit of time and just do a couple of quick examples on this. I'm not going to go through this again unless someone explicitly asked me, because I think they're straightforward and I gave you the solutions. And these, there's no point in going through these because they could be from anywhere. All right, any questions before I do some examples here? Okay, well, I'll keep an eye on the questions anyway. All right, so let's have a peep here. And I took a few of the ones we did and just moved them out into this directory, right, to go through these. So I have 4 things that I wanted to go through with you, right? And I think somebody asked me about this one, right, which was the stack one. Remember this? And this was the one where, I think it was this one they asked me, if not they can speak up. This was the one whereby you were using the 2 semaphores to protect the edge of the buffer, okay? I will say to you, I won't ask you to code, I won't ask you to do anything major with this type of program, right? Because it would be too complicated, right? The message you needed to get here was I can use a semaphore to protect a buffer, right? And in this case, I'm using a semaphore that counts to 10 to protect the buffer, right? So I'm not really going into this one too much other than that, right? So in other words, I have two semaphores here. One of them is counting the number of items in the buffer. Remember, we have a buffer that was 10 long. I have one that counts the number of items in the buffer, and I have one that counts the number of spaces. And the whole point is, every time I put something into the buffer, I will increment this semaphore. So I'll do a sem post, because that will increment the semaphore. And every time I take something out of it, I will decrement this semaphore. So that was the number of spaces. So that would be a sem wait. Okay? So if you think about it, what happens when you start off life, right? So when we start off life, there's nothing in the buffer. So we end up coming in to push. And we do a sem wait on S remains. S remains was 10. There was 10 free slots. And if we do a wait on a semaphore that is 10, what will happen? Will we get queued or will we go through? Am I recording this? Yes, of course I am. So what was the answer? If I do a sem wait on something that's a semaphore that's 10, will I go through it or will I stop? Luke says I'll stop. Anybody else? So there's only one value of a semaphore when I do a sem wait that I will get queued, I will stop, and that's 0. Okay? If I do a sem wait on any other value, the semaphore just gets decremented and I go through. So if I do a push when there's nothing in the buffer, this will be 10, it will be decremented to 9, and I will put the value in. So if I were to do this 10 times, this will go from 10, 9, 8, blah, 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 all the way down to 0. So 10 items will be in the buffer, and then I will come along in the 11th time, and now it will be 0, and I will get queued, which is exactly what I want, because I don't want to try to put 11 items into a buffer that's only got 10. Okay? And that's how pushing works. And popping is the opposite. Let's go have a look at pop. Okay, here's pop. And what pop does is it looks at the semaphore that is counting the number of things in the buffer. And we initialize this to 0. So when there's nothing in the buffer and pop comes along, it does sem wait 0. So it will queue, it will sit there. And it will only get past it when I push something. And look at the last thing I do in the push. I do a post on S items, which will increment S items, which means this one will now get unqueued and run and pop it in. Okay, so as I'm not going to go mad on this one because I'm more interested in the other ones. I'll just show you it run. Sorry, I need to compile it first. So when I compile it, it's pushing. The way this one works is it tried to push 12 items. So push 10 successfully into, and then the popper starts kicking in, right? And so what you were doing there was you were protecting the buffer. That was the whole message of this particular example. All right, we did it in the lab multiple times. I've done it again now, so I'm not going to do it again. I'll just show you the main there so you can see it. Right. Okay, so we go down the end, you'll see. I created 2 threads. I started the pusher, slept for 12 seconds, which means essentially that is going to try to push 12 items because it pushes 1 per second into the buffer. Only 10 went in, the semaphores protected it, and then they got popped out. All right, that's essentially it. The main thing I want you to get out of that is if I want to use counting semaphores to protect the buffer, I'm going to have to initialize them to be the size of the buffer, right? That's the main thing. So there was 10 items. There was 10 items in that buffer. So I initialized S remains to 10. I initialized S items to 0. So if I change that to be 20, I should initialize this to be 20. Okay? That's the main message there. Right. These are the more ones that I needed you to understand. These ones here. So if let's have a look at this one here, which was one of the ones we did, which was, I deleted the wrong line. Apologies, just fix that. So I gave you this one, and I said, okay, so I gave you this program, right? Which is t.c. So if we go and compile it, okay, and I said if you run it, you got I'm thread A and I'm thread B. And what I asked you to do was change the program, and all you were allowed to do was use posts and waits and the init calls to fix the program, right? That's what I told you you had to do. So let's have a look at it. So at the moment, what's it do? It initializes the semaphore. There's two semaphores. It initializes them. It creates thread A and it sleeps, and then it creates thread B. So thread A runs 1 second before thread B. So at the moment, that's why you get thread A. You get this printout coming out before this one. Okay? So I said use semaphores to get this one to come out first. And what that means is we need to stop this one from running until we're ready. So how do we stop thread A from running using a semaphore? That's the real thing you need to understand to be able to do the CA questions. How do you stop something from running? And then how do you wake it up? So how do I stop that printf there from running? How do I stop that printf from running? That's the initial thing we want to do. So we'll do it in 2 stages, right? And it is same way, Ivan. Where will I put it? Will I put it before the printf or after the printf? Before. Okay, let's try that. So Ivan says same weight, same A we'll use. Okay, so Ivan reckons that will stop thread A, yeah? So we try that. Compile it, don't forget to compile it, and then we'll run it. Okay. Unfortunately, that didn't work, Ivan. Why didn't it work? So a lot of you are going, but that worked in the lab. So why didn't it work here? Well done, Reese. Same A, I warned you about this in the lab. Same A is initialized to 1. So I need to get rid of that. Because the same weight, remember, the same weight will not stop. It won't queue unless the semaphore is 0. So now, if I try it, well done. Okay, now I stop thread A from running. Now, of course, the thing is home because thread B got its printout and A is sitting there, right? So we'll control C that. And as I will do it in 2 passes. So we got half of it so far. That'll get you half marks. So how do we wake it up? When we have finished, when we do this printf here, we want to get the I on thread A printf. So we want this semaphore here. We want this thread that has been queued to wake up. How do we do it? Come on, somebody will be here all morning. So we'll do a send post, right? Yeah, look where we put it. Post after the print. Well done, guys. Right. It's as simple as that. Okay. If I do a post on that one, bingo. Okay. Job done. Now, if I were to ask you something that easy on the CA, unfortunately, it isn't quite that simple. On the CA, I ask you to solve the problem, but then I ask you to explain. Because a lot of people, I'll be honest with you, could probably guess and just keep lashing in weights and post until they got it to work. So if you do that, you'd probably be lucky to pass the question, right? Because unfortunately, the question is solve it and explain what you did and why you solved it. So for instance, if you did this one, you would have to say, in words, you would have to say, well, I wanted thread A to stop, so I did the same weight on the semaphore that's 0, and that made it Q there. And then I woke it up from thread B when I was finished my other printf. Okay, so it's that simple, but you have to show an understanding of, in order to get a thread to Q, I must do a same weight on a semaphore that is 0, right? So there's only 3 things you got to watch out for: the initialization values and where you put the weights and the posts. In the question, that's all you're allowed to change. You're allowed to change the init value, this here, and you're allowed to put in weights and posts. Nothing else. You're not allowed to mess with sleeps. You're not allowed to change the order of any of these, right? And it won't be this program, but it'll be something similar. Okay? So that's the simplest one you can get, right? So this one was the next one I gave you, which was a little bit trickier, because this one involved 2 semaphores, right? So again, if we run this, we get meeny or miny, eeny, meeny, mo. Okay, and the whole point was we wanted eeny, meeny, miny, mo. Right, so let's have a look at it. So, let me check something here, sorry. Okay, so eeny, meeny, mo, and miny. So again, do it in, if you get one of these, do it in stages, right? We have eeny, meeny, we want to stop it. We want to stop that one. Well, actually, there's 2 things you need to do here, right? Because look what happens. Thread B runs before thread A. So this one is going to run first. So we need to stop this one first. So how do we stop that? Well, we know how to stop it, don't we? How do we stop thread B? What do we add here? Will we add the same weight or the same post? We'll add the same weight, right? And the other thing we will do is we will check what? What do we check? What do we check for there? Because that's not going to work unless something else. We'll check the init value. In this case, I gave it a 0, so that's nice and friendly, right? But I mightn't always do that. Okay, yeah. So same A, that'll stop thread B. And we also said we wanted to stop. We want to stop this one, don't we? So why don't we put a weight with the other one there, right? So now the 2 of those, they're both 0. So if this works, I should get eeny, meeny, and then I should get nothing. But I'm getting to where I need to be there, right? So let's try that. Let's compile that. Eeny, meeny, great. Now they're both hanging, that's fine, they're both queued, so Control C that. So I'll go in and have a look at this. Okay, so eeny meeny, mo is the last thing we want to do. So the next thing we want to do is we want to wake up this fella so we get miny. So how do we wake up this fella? How will we do that? How do we wake up thread B? We post after mo. Post after mo. Okay. Try that. Which semaphore? A or B? B. A. Think about this for a minute now. Is this right? This is gonna, I've already queued here. I'm never getting to this line of code until somebody does a post. Post before sem b wait. So somebody says this. And is that A or B, Glenn? A. Okay. So I think Glenn might be onto something here, right? So we have eeny, meeny, and then we want to wake up this fella to get the miny, right? Mo is still going to be waiting, and we want him last, so that's okay. So let's try this one. I think Glenn might be onto something here. Yeah, okay, cool. We're there. We're nearly there. Okay. So, what are we going to do? How are we going to get this mo line to come out? At the moment, this thread A is queued on semaphore B. It's that same weight made it queue. So I do a post, yeah. Where will I put the post, Luke? Where will I put it? After the miny print. Okay. And is that a post of A or B? B. Okay. So let's think about that for a minute. So I get print and then I post, and that should wake up this fella here, and I should get mo. Yeah, that should work. I like that. Yeah. As many times as I want to run that, it works. Okay. So be careful. Most of you saw in the lab that you can. What can happen is people can put these in slightly the wrong place, and sometimes it can appear to work, but if you run it 5 or 10 times, you see that it only works some of the time, right? So be very, very careful. You won't get all the marks if you do that. And what happens is you are, like, that is the correct order to do it, okay? In other words, you got to make sure you put the weights in the post in the right place. Otherwise, my advice is when you're actually running it, make sure that when you think you have it, run it 5 or 6 times and make sure that it does what you think it does every time, because otherwise you've got it slightly wrong. And don't forget, again, you're going to have to explain what you did to do this. And by the way, explaining doesn't mean I put a post after that printf. I put away that I can see you did that, right? You've got to explain why it works as regards the values of the semaphores. All right. So that's that one. That's about as it doesn't get much more tricky than that. So if you can do this one and understand it, you should be able to do the CA one, right? Okay. Again, I warn you one more time. Watch out for these values. They're not necessarily going to be 0, 0. Okay. Right, where are we? I think there was one other thing I wanted to show you, which was, yes, the famous script. All right. So I also gave you in the lab a script problem to solve, right? And it was 2 scripts, whatever, and it's all jumbled up like we did with the eeny, meeny, mo stuff, right? And you need to know how to use makedir to get a script to stop. All right. So I have a very, very simple script here, right? So what I'm going to do is I'm going to just show you something, right? Right. Okay. So I have lock and lock2, right? Lock2.sh, when I run it, it does an echo. I'll just clear that, I'll show you. Okay, that's all it does. It does an echo. Now, say I wanted to control that script, and I wanted to say, I don't want you to print out got here until I'm ready for you to print it out. In the exact same way, I could do a sem wait and a sem post, right? So if we have a look at lock.sh, before it, I have this concept here. And this is all you need to understand. You need to understand how makedir and this little piece of code works here, right? So what this does is, again, remember, that's just hiding the screen output, right? So don't worry about that. I make a directory. I check whether it exists. If it exists already, I spin around trying to make it. And the whole point of this is, remember I said, I want to have some way in a script to be able to stop here before I get to echo. I don't want the echo to happen until I'm ready. So I add this piece of code before it. I make a directory. I spin around. If it fails to make it, means someone else has already made it. Yeah. And I will stay here until someone else removes the directory, and then magically I'll pop out of this while loop because this make directory will succeed, and I will get my echo got here. So there's my echo got here, and I want to change the script so that I don't get that echo until I'm ready. So I've added this piece of code. Let's try that script, right? Lock.sh. Shit, I still got the got here. Why did I still get the got here? So it's nearly right, but there's something wrong. Why didn't it work? No, it's not that. That's just tidying up at the end. Look at what it's doing. It's not the file, it's the directory, right? Yeah, exactly. Well done, Conrad, right? So the whole point is I try and make a directory, and if the directory makes successfully, I'll go through that straight into here. The whole point of this is if the make there fails, in other words, if the directory already exists, I will go into this loop, right? So if I want to actually get it to stop. I either have to make it twice in here, or I need my other script. Because remember, typically what's going to happen is there's two scripts, right? So what I'm going to do is, just to illustrate the point, I'm going to do that, right? So in other words, the first one will make the directory and it will succeed. And the second one will try and make it and it will fail. So fail means that the return code not equal to 0, right? And I showed you this before, but I'll show you again, right? If I make a directory called Piersteer, see that? It already exists, right? So let's have a look at the response code. What was it? $question mark. It was 1, right? Whereas if I do this, and I make Piersteer, when it succeeds, I get a 0, okay? And that's what controls that while loop. So I'm just going to remove it again. Okay, now when I run my script, right, and remember my script now has 2 makers at the start, right? Now if I run this script, see what's happening? I haven't got my got there, sure I haven't. So how do I wake it up? How do I get it out of that loop? In other words, how do I control that script to suddenly go, okay, you can continue now. Delete the directory, exactly. So why don't I go over here and I'll just, if I can remember where I was. No, where was it? Apologies for a second. Oh, yeah. Here we go. Okay. Remove there. Here's there, right? Okay. You agree it's still waiting there, it's spinning around. So if pretend this was another script, if I put this line in the other script, bang, this one hops out, right? So one more time. If you want to, this is the equivalent of a sem wait on a semaphore that's 0, right? In a script. If you put something like that in, and obviously, like Jay says, don't start putting Piersteers in all your answers, right? It can be any name you want. It's just a directory, right? A unique directory. The whole point is, if you put something like this, and you don't need the echo waiting, right? So, for instance, it was a bit annoying seeing that all the time, right? So if I do it now, okay, so it's sitting there. I remove it. Bang. Okay. So the whole point is, if you add a piece of code like that, before the line you wanted to stop before, it will sit there until your other script removes. Oh, that's what's wrong. I was wondering. I didn't get the name right. What a god. Okay. Let's just clean it up again. So you put something like this in before the line you want the script to stop on, and somewhere else you do a remove there when you're ready for, you do want the line. Okay, so it's the exact same. Like I could do up a script example of eeny, meeny, miny, mo, and you should maybe do that yourself, an example, and see can you control it, right? So that's all I'm going to tell you on that. You need to know how to be able to control those 5 or 6 lines. And if you decide you don't want to bother figure it out, then that's 5 marks you definitely can't get in ca2, okay? Because there's 5 marks going for a script question. Something along the lines of, can you control 2 scripts talking to each other? Let me see, delete an 80. By just doing the labs, would that be enough for an A? By just doing the labs? I don't know. You have to understand the labs, and you have to be, the questions won't be the exact same as the labs. Wouldn't be much point. Okay. The whole point is, can you apply what you learned in the lab? I say a better answer would be, Amos, if you can apply properly what you learned in the labs, then you have a chance. I don't think you'll see anything major different in the questions that if you did all the labs, you should be able to figure it out. I'm not saying it's easy, but you should be able to figure it out. I'll put it this way: there's people who've got A's beforehand, so they were able to do it. Not the same questions, but similar. Any other questions? Only easy if you make it. Now, why would I do that? So I made the first one easy. Average mark is 60 in ca1. That's easy. For anybody, I'll show you. You want to see the average marks for the RIG questions and the rankers questions. They're like massive, and they were worth nearly 50% of the marks for the CA. So it was set up to make it easier. And CA1 is always easier than CA2. I told you that. Okay, any other questions? All right, not saying that at the moment. If you think of one and you want to ask it, then just email me, okay? And if I think everybody needs to see the answer, then fine, I'll send it out. If not, I will see you next first group Monday at, what is it, 10 o'clock? And unfortunately, because we're doing them all separate, obviously the same questions won't be for everybody. So the questions vary between all the 4 groups, okay? All right, I'll kill it, and this recording will be available in about half an hour or so. Okay. All right. Take care of yourselves, guys. Talk to you on Monday. Be good.